name is Andrew Stoikis, and together with Surya, we are members of the OCP SDN team. Well, actually, I'm a member of Octo team working actively in the OpenShift SDN team. And today we're going to start the first of a few workshops involving OvenKubernetes. So a little bit of background for people who don't know what OvenKubernetes is. It is what is going to be our default network provider for OpenShift. And we have added the links for some previous presentations we've already done on OvenKubernetes. So if you haven't gone through those, this is going to be an advanced deep dive, at least today. It's going to be fairly technical. So definitely feel free to come back and look at this recording, post checking those out. So as I said before, this is the first of many workshops. We want this to be an open discussion. This isn't just going to be me talking for an hour. We're going to bring up OvenKubernetes cluster in kind, an upstream OvenKubernetes cluster, and poke around at various parts of it. So feel free to stop me anytime with questions. This is for you. We want to help the OpenShift group as a whole be better able to understand OvenKubernetes and be better able to go out and debug it. So this extends from other engineers on other teams to support to QE. We want to teach everyone more about OvenKubernetes because it is a fairly complex system. So today we're going to start small. We might not even take the whole time. And based on feedback, we can continue to iterate on these workshops. So for today, some things we wanted to run over were basically understanding the OvenKubernetes deployment. So I'm going to talk about the OvenKubernetes deployment in Upstream, which is a basic kind deployment, and then also in Downstream OpenShift, because they do vary a little bit, and that tends to confuse a lot of people. And so we want to iron all those details out. So the next thing we want to do is show everyone how to do some traces. There's two main tools today we're going to be using for tracing. One is OvenTrace, and the other is OF-Proto-Trace. OvenTrace traces essentially a simulated packet through the Oven logical network, while OF-Proto-Trace does essentially the same thing at a lower level in OVS. And we're going to be showing those traces for pods running on the same node, different node. Is there anything else you want to add before we get rolling, Surya?
No, go ahead. Yeah, that was good introduction.
Great. Okay, so diving right in. The OvenKubernetes deployment, I'm not going to go into each component of Oven and OvenKubernetes that we deploy to get everything up and running. This is a general overview. Two of the main ones we want to see from the OvenKubernetes side are the OvenKubernetes master process and the OvenKubernetes node process. The other stuff are various Oven and OVS processes that are run in different ways depending on if we're in upstream kind or in downstream Oven OpenShift. So in upstream kind, the way we deploy OvenKubernetes is with deployments, a mix of deployments and Damien sets. So, and all processes are started from this OvenCube.sh script, which I added the link to here, so feel free to go check it out. The two deployments that are run on the kind cluster are OvenCube DB and OvenCube master. So OvenCube DB is the deployment running two containers, NB OVSDB and SB OVSDB. Now, these are Oven components that are essential to how Oven functions. So I'm not going to, again, go into each component. Please check out the previous slides. Just want to explain how it's deployed on an upstream kind cluster. The next deployment is the OvenCube master deployment. So this deployment runs on each master node, and it includes three containers. The containers are OvenCube master, the NVCTL Damien, and Oven North D. OvenCube master is kind of the most important one from an OvenKubernetes point of view, right? It's the central control plane for the rest of the OvenKubernetes cluster, and it kind of helps manage what Oven entities are programmed into each node. In upstream kind, the NVCTL Damien is essentially just a running log process that shows every NVCTL command that is called by OvenKubernetes. And you'll see later on, this isn't something that's included in the downstream deployment. The last one is OvenNorthD, which is a core oven component. So it's just deployed by OvenKubernetes. It's not created by OvenKubernetes. And it's what essentially translates logical flows down into OpenFlow flows in the SBDB. Great. So still on the upstream deployment, the two Damien sets that are used are OvenCube node and OVS node. So OvenCube node runs on every node, and it has three main containers. It has OvenCube node, which is kind of confusing, right? The Damien set is the same name as a container running inside it, but it's just kind of how it worked out here. Oven controller and OVS metrics exporter. The two really important, well, the most important one is OvenCube node, right? It's the per node process that OvenKubernetes runs in order to directly manage OVS configuration, oven configurations on that node. Whereas the oven controller is an oven process that converts OpenFlow flows into physical flows. So if you're familiar with oven, you should know what oven controller is. The last Damien set I wanted to call out on the upstream deployment was the OVS node Damien set. So this is an important differentiator between upstream and downstream deployments. In upstream, OVS is running in a container on each node. Okay, OVS is the underpinnings of all this, right? It's the bottom of the stack, what is programming physical flows into the node's interfaces. So in this upstream deployment, the OVS Damiens run this essential service. And if we want to run any OVS CLI commands, we have to get into those related pods. Great. So now moving downstream, right? OpenShift, that's what we're all kind of interested in. We want to learn how to better debug OpenShift when OvenKubernetes is running as the CNI. So one of the main things that I'm going to point out right away, OVS is now run on the node via systemd. And I linked the script there. That's part of the machine config operator that actually starts up the node, the OVS on the node. But then hopping back into the deployment, there are no deployments for OvenKubernetes in OpenShift. There's only Damien sets. So the main reason between having different deployment styles from upstream to downstream is we need to be able to support a HA mode for OvenKubernetes. So this includes running NVDB and SBDB in Raft or high availability mode. And we just couldn't do that with the upstream work. So instead, we kind of do everything a bit more manually within the cluster network operator. And that's where we kick everything out. So just running through it really quick, for the OvenCube master Damien set, it runs on master nodes. And there's actually 6 containers in this Damien set. I'm not going to go into each one. It's pretty self-explanatory based on our previous explanation. But essentially, the main thing I want to call out is that the OvenCube master process is no longer, oops, sorry about that, no longer started by the same default script that we use in upstream. We're actually doing it manually. Oh, sorry. Awesome. The other containers of note here are the Kube RBAC proxy. That's essentially just a proxy to perform RBAC authentication. This is run in, I believe, most operators in OpenShift. And then the last one is the OvenDB checker. This is a custom container used by OvenKubernetes to make sure that the database health and wrath membership is running as we expected and correctly, and everything's clean. So the next Damien set in downstream is OvenCube node. OvenCube node has 4 containers. Like I said, most of it is the same as upstream, but there are 2 that aren't there, which is OvenACL logging and Kube RBAC proxy. The proxy container is the same as before. The Oven ACL logging container is essentially just a container responsible for tailing ACL logs from the Oven controller so that the logging stack can pick up these logs in an easier manner. Otherwise, the Oven controller and the OvenCube node are essentially the same processes as in Upstream. Awesome. So what I'm going to do now is start hopping back and forth between my terminal and this PowerPoint. The PowerPoint I built as kind of a reference piece to go back and look at what we've done today, and also a kind of source of truth for me. All the stuff I'm working on today has been included in a Upstream or a repository on my local GitHub that includes the NBDB and SBDB files for this cluster. So you can actually run Oven traces with the static instances of those. So anyway, let's go ahead and get started and look at some of these useful commands. Now, everyone might know some of these commands, some might be new. The main problem with these commands isn't the command itself, it's where to run them on an OpenShift cluster, right? So for now, I'll just run through them really briefly. NBCTL show is really important. It shows the logical topology of the Oven-Kubernetes cluster, whereas Oven SBCTL show does essentially the same thing for SBDB. Some other things we're going to need for building traces today are OVS VSCTL commands and OVS OFCTL commands. There's a lot of ways to skin a cat with these. These are just the commands I've used today to build the traces I'm going to show you here in a minute. Great. And then also some other commands you'll see today are ARP and TCP dump, which are just basic Linux commands. Often these tools may not be included on the node, so just be aware of that. The way I brought them in were with custom containers. Great. So let's hop onto this cluster. So today we have an Upstream kind deployment that's running local gateway. So I have terminals up here for all of my important stuff. And I also have some text files, including some data that we're going to need later on. So first things first, I say we're running local gateway. Like, how do we know that? Let's hop into one of those OVS Damien pods and check it out. So this is the OVS node pod running on Ovenworker. And here I can run OVS VSCTL show to give you a brief overview of the OVS topology. I know this is a local gateway cluster because we have a bridge local bridge, which we don't have in a shared gateway cluster. To understand that more, please go back to the previous slide, the previous link slides. We talk a lot more about shared gateway versus local gateway, etc. For today, I just have a local gateway cluster, and I wanted to show everybody how I determine that if I'm just getting on a new cluster and I have no idea what's going on. Great, so we know what kind of cluster we're on. Next thing we want to do essentially is kind of look at the root of truth here. So first, before we do that, I need to talk a little bit about the Damien sets I'm using today as test Damien sets. So let me pull those up. As you can see, I have a number of pods running in the default namespace that I'll be kind of poking around and using today. I deploy those with 3 Damien sets. One is a client Damien set, one is a server Damien set, and then one is a tools Damien set. The client and server Damien sets, which I've included in the Upstream repo, are running 2 containers. One is a Agnos container used in Upstream Kubernetes CI often. It's super helpful. It's just running a basic HTTP server that has some nice endpoints such as client IP and other cool things. And then also a tools container, which is just a CentOS tools image, which includes TCP dump and some other super useful commands. And then for the tools Damien set, it's just the CentOS tools image. And the important differentiator here is it's running host networked equals true. So as you can see, those 3 pods that are part of the tools Damien set are host networked and have IPs that are the same as node IPs. Great. So let's go ahead and get into a client pod and see what's going on there. So I'm going to start on Ovenworker in the client pod 89JWT. I actually already have a terminal up for that. So this pod is just a normal pod. It's running an HTTP server. But in terms of network, like, let's see what it knows. So currently there's 2 entries in its arc table. These entries correspond to Oven logical MAC addresses and entities. So the 0001 relates to the STOR port on Ovenworker, which we can verify by checking out the Oven NBCTL show. So as you can see, the default gateway here is essentially the Oven cluster router for a pod. So when we first spin up a pod and you're sending traffic anywhere, that's kind of where the next hop MAC address is going to be assigned. The next MAC that's already in this table, because I've been poking around at it, is another pod that is on the same node. So that is the server pod, which is nice because it allows pod to pod traffic to run without going to the Oven cluster router. Cool. So just to prove to everyone that this is working, I can curl the server pod on the same node. It's running at port 800. And because it's a client Agnos container, I can actually see client IP and see what my client IP is and see that it's succeeding. Great. So we kind of have an initial overview of where we are to start with some of these pods. Now let's talk about what everyone really wants to talk about, which is tracing. So in most debugging scenarios, you want to make sure that OvenKubernetes thinks traffic can flow. If OvenKubernetes thinks traffic can flow and traffic still isn't flowing, then we need to go a layer deeper and look at OF prototrace and make sure that that thinks traffic is still flowing. So how do we build traces with these tools? This seems really easy for some more advanced people, but for a lot of people, this may not be as apparent. So we're going to kind of dive into where I find the data to build these traces. I also provide here some generic examples. So normally what I do to build these traces is I have a text file open with a generic example. And as I find the data I need around Oven and OBS, I copy and paste what I need into there. So the first trace we're going to do is pod to pod on the same node. So this is going to be OvenKubernetes Workshop client 89JWT pinging the server running on the same node, which we already did and showed that it's actively working here. So now let's see what an Oven trace looks like when we do that. So how do I build this Oven trace? As you can see, it's a, oops, sorry, I keep clicking through these by accident. As you can see, it's a pretty generic setup. Like you're able to just copy and paste, import, next hop MAC address, source MAC address, et cetera, et cetera. But where do we find all this data? Let's check it out. So for Oven trace, most of your important data is going to be in your Oven NBCTL show command. So to run that command, we need to get into the OvenCube master pod in the OvenCube master container because it has access to both the Oven NBCTL Damiens and the SBCTL Damien. Once we're here, and I'll make this cleaner for y'all. Then we can run Oven NBCTL. And we have the high-level logical representation of our network. As you can see, we have a switch for each node. This one is for Ovenworker 2. Ovenworker is the one we're kind of worried about. And we also have the Oven Cluster Router, which is the other central piece here that we'll be working with. So to start, we need to find what our import is going to be. So what is the import in this flow from an Oven point of view? And we can find that pretty easily within the Oven NBCTL show. You just find the relevant switch, which is Ovenworker. And we can see our client pod has a port attached to it with a name, a MAC, and an IP, all of which we're going to need here. So as you can see in the first trace, the import is that port we just looked at. The MAC source is the MAC of the pod, and the MAC destination is the MAC of the client pod, or of the server pod, sorry, excuse me, which we can see on the same node right here. Some other things to note, you can also specify the protocol, the TCP source port, which you don't have to do. The TCP destination port obviously is pretty important. And OvenTrace also has a concept of layer 3 where you assign IPv4 source and destination. So now that we've built our trace here, we've seen where to get all the information we need, which is basically all from Oven NBCTL show. Where do we run this trace? Someone might ask. I won't take this all out because it would bore you even more, I'm sure. So we are still in the master pod where we ran the Oven NBCTL commands. We can run the trace there as well. So let me just exit and clear this so it's a little easier to read. Copy and paste our trace. And let's step through it. We're not going to go into a super detailed look at the trace today. The main thing is that traffic is ending up where we expected it to end up. So as you can see, we start on the ingress pipeline of the Ovenworker switch. We never actually make it to the Oven cluster router here because the destination pod is on the same switch. And we end up outputting to the correct server pod. So from an Oven point of view, traffic is working, right? We're coming in at the client pod and we're going out at the server pod. So that's great. So what would happen if Oven was saying this flow should work, so the trace looks good, but then we exec into the client pod and tried to ping the server pod and it didn't work. So that's when we need to dive a little bit deeper and do an OF proto trace. So OF proto trace is pretty much doing the same thing, just at a lower level. And they can be even more daunting to build for someone who's not as familiar with OVS and Oven. So let's take a stab at looking how we're going to do that. I've already posted the trace here. It essentially has most of the same fields. The main one we're going to look at trying to figure out now is the import number, because that's kind of the most confusing thing. The DL source relates to the MAC source. DL dest is MAC dest. Those are the same as for the Oven trace, and that is the same as for the NW source and NW dest source and destination IPs. So let's check out how can we find what this import number is going to be. So essentially what we need to do is find the VF pair that OVS is using to program the container. To do that, we have to go back to our OVS Damien running on Ovenworker, and we have to run an OVS vsctl find interface. Now, this gives a lot of output. For readability's sake, I've went ahead and created a file for it. Let me just go ahead and copy my pod name because that's what I'm going to need. So OVS interfaces Ovenworker 2. So what I usually do here is output to a file, and then I can use a simple search to look for my client pod. So where I think the traffic is originating from. As you can see, that narrows down my search to the actual interface that OVS is using to program the container. This interface has an OF port number. That OF port number is going to be the import in our OVS OF proto trace. So let's try it out. So because OVS OF proto trace is part of OVS, obviously we're going to run it in the OVS node pod. As you can see, my import is 10, which is corresponding to the correct OVS interface, and the rest of the information is the same as the oven trace. Ooh, live failure. That's what we like to see. I didn't exec back into my pod. Sorry about that. Great. So right away we can see one of the more important things we want to see is where did this packet get outputted to? It got outputted to port 11, and we're on Ovenworker's interface. So what is port 11, we might ask? We can do the same thing. Go to my interfaces file, find OF port 11, and see, oh, sweet. It's the server pod running on Ovenworker, just like we expected. And again, this OF proto trace is synchronizing with what OvenKubernetes already said, that traffic is flowing as we expected. Today, I'm not going to go too much deeper into steps of this OF proto trace. The main thing we wanted to see is that the packet was getting outputted to the correct port. Great. So PodToPlot on the same node is pretty easy, right? It's not super complicated to understand. Things get a little more complicated when we're talking about PodToPlot on different nodes. So I'm going to try to go a little more in depth here, believe it or not. We're going to start with a TCP dump showing the traffic between the nodes in 2 different places. And then we're going to go forward from there into building the actual traces. So now we're on pod-to-pod, different nodes. So for this example, we're going to be going from a client pod, the same client pod on Ovenworker, to a server pod on Ovenworker 2. So let's verify that that even works. So as I said before, we're going to be going from the client pod running on Ovenworker to the server pod running on Ovenworker 2. So let's see if we can curl Ovenworker 2's IP. Oh, forgot my port. Great. As you can see, the curl is working, so traffic is flowing. let's see what those packets actually look like. So I'm going to go first over to one of the tools pods running on Ovenworker 2. So this is seeing what the node is actually seeing. It just brings in the TCP tool that we need to use. Great. So that's running. Let's try this curl again. And then go check out our TCP dump. Ah, we caught some traffic. Sorry, it might be a little hard to read, but some of the most important things we can see is that the traffic is coming from our client pod at 10.244.0.7 to our destination pod 10.244.2.9. Now, this is actually within the server pod itself. So we're not seeing any of the Geneve encapsulation data here. We're just seeing some of the final payload, which is the first packet is the TCP SYN from our source to our dest. But we want to dig deeper. We want to see what this packet looks like before it's unencapsulated by the kernel and oven. So to do that, I actually need to get into one of these host networked pods. And again, we're going to get into the one running on Ovenworker 2. And run the same thing. Oops, sorry about that. I actually wanted to show just the packets coming from my Ovenworker, which is host 172.18.0.2. Great, now we aren't getting spammed. The reason we were getting spammed before is because you're seeing a lot of the health checking traffic coming from the control plane or master node. So again, let's go to the client. Let's ping the server. And let's see what we have down here. So now we have a bunch of packets. I'm going to start with the first one. As you can see, we have a packet from Ovenworker at .02. Sorry about that. Resized. At .02, coming to our destination node Ovenworker 2 at .3. This packet in its state is still encapsulated via the Geneve protocol, and that is unwrapped within Oven. So just to be thorough here, we're seeing the Geneve packet come in, and then by the time it makes it all the way to the actual server pod, we've dropped those Geneve headers, and we just have a normal generic packet. Awesome. So traffic's flowing. We can see that it's flowing correctly via the TCP dump. So let's hop back into our trace world. For the Oven trace, it's pretty easy. It's kind of a lot of replication from the pod-to-pod case. All the data we need for the Oven trace is still in the NBCTL show. The one main difference is that the next hop is no longer just the server pod. And that's because we're on different nodes. So what is this next hop? What is this MAC address? Let's go check it out. So on Ovenworker, and in every node switch for that matter, there is a port that starts with the abbreviation STOR. That stands for switch to the router, basically, essentially. And this is going to be the next hop for our oven trace because the destination pod isn't on the same switch. So we have to go to the router in order for routing to actually happen. So let's go back to the OvenCube master pod and run that trace, make sure everything's working correctly. So the oven thinks that the traffic should flow is correct, right? Client to server pod. Now, the only difference is this server from the original one is this server pod is on a different node. This oven trace is actually a bit longer because rather than just executing the ingress and egress pipeline for Ovenworker, we actually have to go to the pipeline for Oven Cluster Router, which essentially is routing that traffic to our destination node and destination pod. Now, this again is pretty simple. It shows our import and output. We know where everything's going. Everything looks good. An OF prototrace, things get a little more difficult because what you're not seeing under the oven covers here is the pod actually, or the packet actually leaving the default interface bridge F0 on the source node and entering the default interface on the destination node inside of that Geneve packet. So let's check out how to do that. Great. So in order to trace this whole scenario, we actually need two OF proto traces. We need one run on Ovenworker and one run on Ovenworker 2. The one on Ovenworker traces from the source pod interface essentially out to its Geneve tunnel port, which can be seen in the OVS VSCTL show. The second trace is a bit more complicated. It actually needs to represent the state of the packet as it left the source node, and it needs to define that the import for that trace is going to be the Geneve tunnel port on the destination node. So the first trace is pretty easy to build. We would do it in the same way as we built the OF proto trace for the pod to pod on same node case. The one made differentiator here is instead of the MAC dest being our destination pod's MAC address, it's actually that special port we were talking about before. So 0001 corresponds to our STOR Ovenworker port on the Ovenworker switch. So that's kind of the main big difference with the first of those traces. And let's see that in action. So I'm going to go back to my OVS Damien on Ovenworker, and we're going to run this thing. Great. And again, I'm not going to go through everything, but right at the end of this trace, we can see the output port, which is 2, and that the output of this packet is to kernel tunnel. Sweet, that's what we wanted. Let's go a little deeper. Let's see what this output :2 actually means. To do that, we need to, again, go look at all the interfaces for all the OVS interfaces for Ovenworker. And we can search for Geneve. And see, there's actually 2 tunnels here. The first one, its remote node is 04, or 172.18.0.4, which is actually the oven control plane. So that's not the one we want. It's not Ovenworker 2. Or Ovenworker 3, sorry about that. Ovenworker 2 is Ovenworker. So as you can see, this is the actual interface that the OF proto trace signals the packet going out of. Its OF port is 2, which corresponds to the output we see here. Now, the hard part is when we have to trace that packet coming into the Geneve port on the destination node, which is Ovenworker 2. To build that trace, I've shown here, obviously it looks way more complicated. We have to use some of the information that was provided to us in the final flow of the first OF proto trace. This final flow essentially is representing the state of the packet as it leaves that source node from OVS's point of view. Some important things we need to copy over are all these register values, along with the same VLAN TCI ID and all these other original source and destination addresses and MACs that were the same before. Another really important thing to note is the ton ID and ton metadata. So ton ID we can find pretty easily right here. We have to manually copy those over. The ton metadata, if you'll notice, actually signals as NP here. So it's essentially like, the Oven team might be able to clarify this a little better too, but it's essentially a hash of this Geneve settings. And so the actual value for that ton metadata 0 here, it can actually be found here as 0x10006. So as you can see, copied it over here. We have ton ID 0x6, ton metadata 0x1006. And the rest of the data pretty much stays the same. The one thing we do have to fix, okay, is the F source and F destination. So on Ovenworker, the F source was the source pod. Obviously, the F destination was the STOR port on the Ovenworker switch. Now, the F source, once we're on Ovenworker 2, is the STOR port on Ovenworker 2, and the destination is actually the MAC address of the destination pod. That's an important thing that hangs some people up. So let's see this trace in action. Again, now, because we're wanting to do the trace on Ovenworker 2, we need to make sure we're in the correct OVS Damien. Let's run that and see what it looks like. Great. So again, not going to run through all this. We can see that at the end of the day, the packet is outputted to interface number 12, but we don't know what that is. So again, we need to do a quick look at the interfaces, this time on Ovenworker 2, and see what OF port 12 is. Is it the right one? So interface 12 corresponds to default OVN-Kubernetes Workshop server XQ8TV, which is in fact the correct destination pod, as you can see here. Great. So in conclusion, this is just day one. We want to hear feedback, how we can make this better. It's pretty dense. It's hard to wrap your head around, but I think, understanding how Oven Kubernetes works and how to run these traces is really important in debugging, ultimately debugging OpenShift clusters, because most of the time, the problem we're seeing is traffic is getting dropped somewhere along the way, and these traces can be a really good indicator of where that's happening. So again, thank you so much for today. I want to leave, I think I left about 14 minutes for questions. So love to get some questions on this stuff. Again, I know it's super dense. Also would love to get some feedback on what you want to see for next time. So yeah, I'm going to go ahead and open up the floor unless Surya has anything else to say.
Just one thing I want to point out, like we discussed in the chat, both OVN and OVS are simulations. So you need to kind of know the topology before you can build a trace, and that might be a bit hard in some cases. Like if you go back to the OVN trace, most of the fields are actually intuitive except for eth.destination, which has to be the next hop. And if you need to know what the next hop should be in your topology, then you need to know how it's all built up. So we also have a wrapper around this called OvenCube trace that Mark mentioned in the chat, which sort of builds on top of OVN trace, and that kind of automatically determines what the next hop should be. That might be easier for folks to use than the raw oven trace, although the OvenCube trace does not work for all the scenarios, just in FYI. Yeah. I think we can take the questions now.
Awesome, thanks. Yeah, we can definitely do a demonstration of a OvenCube trace. Does anyone have any questions?
Hey, this is Rafael. I have one question. It felt a bit complicated to me to follow everything. Do you guys have planned to put a front-end UI in front of all of this and just let people see the topology and maybe pin two pods and say, I want the trace between two pods? This kind of user actions that were, I think it was something that the project Skydive was trying to do. I think it was a project for OpenStack, but OpenStack not working.
Yeah.
So anyway, is there a plan for a front end to simplify this kind of operations?
That's actually a very good question. Thanks for asking. So firstly, we want to mention that these trace tools are sort of more for the people who are debugging behind the scenes, like for support and also for us. We don't recommend customers to know the details of this. And question about, do we actually have a UI or do we have plans for it? I think the network observability team of OpenShift is actually looking into the Skydive project, and I know that there was some movement there. I don't know if Russell's on the call here. Is Russell here?
So network traces come from, you need network traces to address two requirements. One is troubleshooting, okay, and I can agree with you, but very often we're also asked to have network traces by the security team. Right. In that case, sometimes they want persistent network traces that push this network packet to another system that then does downstream analysis. So I'm not sure if this feature is also taking that requirement into account. But for those kind of configuration, a front end would certainly be useful.
Yeah, agreed. I know that there was one person on our team who was working on this. I don't know the exact status of this right now. But okay. There's definitely a Slack channel called Forum Network Observability, and you might definitely get your answer in that channel.
Yeah, and there's work being done on an easy to use way to verify every flow that's relevant in an OvenKubernetes cluster. So today we went over two of the simplest, super simple flows. There are a lot more, okay? And there's work being done to essentially automate a testing of every single flow that's relevant and then also give you the traces. But it's important to know like how we got there, not for everybody, but for some of the lower level engineers. And it's also important to understand how it's deployed in Upstream, which is kind of why we decided to present both today. Anyone else have any more questions, feedback?
Yeah, I have a few. First of all, I'd like to know how the northbound traffic works. Is it similar? How can we debug that? You showed pod-to-pod traffic, but what about external traffic? The second thing, is there some thinking about creating a simple CLI tool? We give it source and destination pod, and it actually builds all the trace information pull out the trace instead that you need to go and search for everything. It would be simpler for customers and us to debug stuff and see stuff.
Yep, OvenCube Trace is that tool currently. So we wanted to show kind of what was going on behind the scenes and how to find some of this stuff that was relevant. But there is a tool. It works for some of these simpler cases, but for more of the complex flows, like external traffic, ingressing and egressing, it doesn't work. It's not fully complete yet. So once that tool is iterated upon and perfected, then we'll go ahead and give a presentation for more of like a customer-facing tool that can be used way more easily by support engineers. And we will definitely be doing more flows describing north-south traffic in more of these workshops. Yeah, go ahead, Lizek. Do you have a question?
Yeah. You mentioned that in the current deployment, there's nbctl d1 container that logs all the nbctl commands. Like it's an audit log of the changes over time. Is there something similar in the OpenShift deployment?
Yes, we log. We have logging for the nbctl Damien, and it's persisted in a file on the host. Off the top of my head, I can't remember exactly what the name of that file is, but we do have something equivalent for downstream, I believe.
Oh, okay, thanks.
Great. Well, if there's no other questions, I know this is a super complex topic. I know some of this was probably pretty hard to sit through. It's very dense, but we want to start doing these traces live so that people can go back if they run into a certain scenario on a customer cluster and understand how to look deeper. We need to assimilate the OVN-Kubernetes technical knowledge kind of out if we're going to support it as our default CNI. So that's kind of the main goal of these workshops. Again, it's a work in progress. Love to hear feedback. Feel free to ping me, email me, or Surya, or reach out in the Team SDN channel. We're doing these for you. Like, we work on OVN-Kubernetes every day, and we want to help spread the knowledge. So please feel free, comment, send messages. But otherwise, I think that's all I have for today.
Yeah, the next session will be 2 weeks from now. I've edited the calendar to make this bi-weekly so that everyone gets a chance to go and play around a bit. Because like Andrew said, in the future sessions, we're going to have a bit more complicated scenarios like north-south traffic, which is not as simple as the two simple cases that we saw today. So if you feel that this way of tracing and doing is good enough to move forward, please let us know. If you feel we need to improve on something, do let us know of that as well. Yeah, thank you so much.
Yep. Great. Well, I hope everyone has a really good day, and we look forward to hearing your feedback and learning together about OVN-Kubernetes. Okay. Bye, y'all.